Welcome back everyone to the second video in this Python series where I go over basic and advanced Python features. Now that we have an introduction to the Bash shell and also to the pip installation manager, let's go over some essential concepts of Python. Concepts that you really need to get a good grasp on before you start tackling things like NumPy, Pandas, or even other programming languages, honestly speaking. So let's go ahead and take a look at these concepts. They are conditionals, misspelled, which are also known, which I'm also going to tie in with booleans, loops, data structures, list comprehension, and also some introductory basics to Python. Now, the way this video is going to work is that I'm going to teach you all, or rather demo a concept for you. Then I'm going to give you some challenges within the notes, just like before. I'm going to challenge you to pause the video, try to implement or predict the output yourself. Then we'll go over the answer and see why an answer is right. And then after we're done going over all these 5 concepts, we are going to take a look at the emailfixer.py file within the challenge 2 folder of Fix Me Week 2. Keep in mind, I gave you all an optional Python assignment where you were tasked with fixing some Python code, some erroneous Python code. After we're done going over these 5 concepts, you should be in a good place to implement this yourself. And once again, I challenge you to do exactly that. Try to work on this file yourself. Try to implement the code yourself before you go through watching this video. All right, so let's go ahead and take a look at this description before we take a look at our 5 concepts. Tragedy has befallen our company and our database of client emails was hacked. Surprisingly, nothing was copied or stolen. Doubtful. Instead, they went through all of our client emails and inserted random characters into each email. So this is a very strange hack. They really didn't profit off of this. They basically just made our jobs harder, kind of like a silly hack. And let's take a look at what they actually did to our emails. So as you can see, we have this email right here, bob@gmail.com. And let me lay down some assumptions for you all. So the assumption is the only valid characters in this string are the @ symbol, dot, and also any alphabetic characters. Anything else should not be within this email. That includes numbers, special characters, anything that's not one of these types of characters should not be in this email. So in the end, we should have bob@gmail.com, yasmin@yahoo.com, and then lastly, let's see if I can remember who's last, ahmed@company.com. Anyways, before we tackle this this debugging task, let's take a look at our notes. All right, and just as a warning, this is going to be a bit of a longer video, so feel free to watch this at an advanced speed. All right, so I'm going to go ahead and share another VS Code. Here we are. All right, so let's talk about the Python programming language. So not only are we interested in understanding statistics and some good database practices, we really should understand Python, the ins and outs of Python, and understand what's efficient code and what is inefficient code. And honestly, this is a great introductory programming language. However, I still recommend taking a look at these other programming languages, C, R, and maybe Scala if you're up for a challenge, but primarily C and R, definitely. So let's talk about Python. And if you're already familiar with all these features, then go ahead and skip ahead. So Python is typeless. That means when you create a variable, you just write the variable name. X is equal to 5, easy as that. You are all going to see that when you start working in other programming languages, that assumption does not exist. You'll see things like int x equals 5. And honestly speaking, I feel like this is better for an introductory programming language because it tells you exactly what kind of variable you expect. Here, you can basically rename variables, whatever you want, and there's no kind of separation of data types. Anyways, I'm not here to insert my opinion. Let's keep talking about Python. Python is an interpreted programming language. Basically what that means is that when we run Python in our terminal, when we type in Python and then the name of our file, file.py, what actually happens is that Python, this thing itself, is actually a program that takes your file and it reads it line by line, and it does some sort of action on your computer based on what you've written in. A compiled programming language is completely different. Basically, what happens in compilation is that it takes your file, translates it into machine code, a bunch of like ones and zeros, something that only a machine can understand. And then instead of executing the file directly, we actually execute the compiled file. Now, of course, compilation is much faster than interpretation after the first time we compile or build this machine code. So yeah, that's also something to consider. And lastly, I just want to bring up one last thing. Python is an object-oriented programming language. That means everything in Python is an object. And keep in mind, an object is a bundle of data that contains details and behaviors. And this is basically our attempt to model the world. We think of the world as discrete objects interacting with one another. Now, of course, this is not the only way to think of the world, or not only the type of programming language that exists, but for now, we're interested in object-oriented programming languages. So yeah, if you create a variable called x, set it equal to hello, you can apply methods to it, x.upper. This is object-oriented programming at its best. All right, so now that we've gone over some basics, let's go over some conditionals. Now, by now, you should be familiar with assigning variables. You should be familiar with the process of creating a variable, naming it whatever you want, something descriptive hopefully, and setting it equal to some data. There should be an intuitive method. You should not have to think too much about this at this point. We've been working with this kind of paradigm for about the past 6 months, so hopefully you're used to creating a data frame and setting it equal to some sort of object, whether it's an integer or a data frame. Okay, let's go over conditionals. Now, conditionals is part of control flow. Basically, control flow is when we control what part of a program executes when. Essentially, conditionals are essentially when we want code to execute conditionally. And if that doesn't really explain anything, let me break that down. We want code to execute only if a certain condition is met. Think of this as a contract. If you get the job, then you get the salary. Something along those lines, right? So that is an example of a condition. Think about it like a contract, and think about this like a contract that the program honors. So essentially, it's looking through a bunch of conditions. It's looking through a bunch of logical statements, and if one of those logical statements is true, it's going to execute the subsequent part of your program. Now let's talk about the structure of a conditional. Basically, we start out with an if statement. We always start out with an if statement. Then we write some sort of logical operation, or rather logical sentence. We'll talk more about those later. If that evaluates to true, then great, we execute this print statement. However, let's say this evaluates to false. Well, no worries, we have that else if statement. So basically, we're going to move on to else if, and if that evaluates to true, perfect, then we'll just execute this statement. However, let's say even the else statement evaluates to false. Well, that means we need to finally go to the else statement. Think of an else statement as a means, basically the last possible condition that can be met. If everything else is false, then we have to execute the else statement. There is no other choice. If we don't have the else statement, that basically means none of these subsequent statements get executed. We just basically exit out of the program without printing out anything. Okay, so let's move on to what a conditional statement is. Now, conditional statements are basically just, or rather logical statements, are just true or false statements, something that can evaluate to true or something that can evaluate to false. In mathematics, we call this a proposition or propositional logic. Basically, we have some sort of sentence like the sky is blue, and that evaluates either true or false. And we often represent these logical statements as variables in reality. So, for example, let me go ahead and write out a variable, p. And often we represent this in p's and q's for some reason. Can't remember why. But anyway, p. Let's say p states, let's see, dogs usually have 4 legs. Q represents trees grow. What's something they don't grow? Trees grow paper clips. Now, we have two logical statements. Sorry, I didn't tie this into something a little bit more grounded in reality, but essentially, we have these two propositions. This one's a little bit fishy. Usually, we want something that states a definite true or false statement, but we're going to evaluate this to true and evaluate this to false. And as you can see, we use T and F to refer to true or false statements. Oh, excuse me. Had a sneeze there. All right, so let's talk about some logical statements. One type of logical statement or logical operator we have is a conjunction. So logical operator. So in the world of mathematics, everyone, we have operators that we use to create new values. In the world of logic, we have logical operators. We have conjunctions. Conjunctions are your AND statements. And AND statements are sticky, or pardon me, false statements are sticky in AND statements. So it doesn't matter how many true values you have in an AND statement. If one of them is false, the entire thing evaluates to false. Notice what we have here. We have three true statements, and then finally we have a false joined with an and. That means the entire thing evaluates to false. So yeah, that's how conjunctions work. We often even represent them with a caret, sometimes an ampersand, or in Python, an and. So keep in mind, in logical statements, we use ands whenever we want to make an entire statement false if one statement is false. All right, next let's move to ORs, or disjunctions. Disjunctions are true sticky. If anything is true, the entire statement becomes true. Let's say, for example, we have two false, one second. Sorry about that. That was a live fix. Anyways, let's say we have a bunch of false statements, all joined by ORs, but then finally you have a true. Well, that means the entire thing is going to evaluate to true. Doesn't matter if everything else was false, as long as you have a true at the very end or somewhere at least once, the entire thing becomes true. Think about it like this. When a waiter says soup or salad, and then let's say you select one of these things, or rather, yeah, just in the menu it says you either get soup or salad based on availability. If they bring out soup, you're not going to get upset and state that this statement is false, because they indicated either one is going to be true or the other one is going to be true. That's how OR statements work. Then finally, we have negations. And as you can see, negations are simply the opposite of your truth value, the opposite of your truth value. And we often represent this as this sort of symbol, or sometimes a tilde. And once again, keep in mind, not statements, or rather logical operators, go from inner to outer. So if you have something like this, not true, this could be represented as not and not true. So what you're going to do first is evaluate that innermost true statement, so not true, that's false. And then you're going to evaluate that outermost true statement, or logical operator, so that's not false. So not false indicates true. Think back to kind of like riddles and stuff. Now, one thing that you're going to notice is that if you initially have a true statement, or whatever statement you have, if you have an even number of negations, it evaluates back to what you had at first. If you have an odd number of negations, you'll evaluate to the opposite of your true statement. However, you're probably never going to see that, realistically speaking. Okay, so now that we've talked about logical operators, I just want to emphasize that these are not the only logical operators that exist, and in addition, you might see a combination of logical operators. Sometimes you might see something like this, T and F, or T. One thing I want to point out in this case is that in order of precedence, first we do ands, then ors. Sorry, give me one second. Yep, I thought so. So first, actually, you're going to do nots, then ands, and then ors. So not goes first, ands go next, or conjunctions go next, and then finally disjunctions go last. So I want you all to take a second and think about how to evaluate this logical statement. Feel free to pause the video, and then we'll talk about the correct answer. All right, so let's go ahead and solve this together. True and false, what does that evaluate to? Remember, ands are false sticky, everything becomes false. But then we have true or false or true. Think about it, falses are, or rather ors are true sticky, so this eventually decomposes to true. So yeah, this kind of logical algebra is important to understand because you are going to be doing a lot of it in the world of computer science. Okay, let's move forward. All right, so you are all going to notice that I have 4 questions. Go ahead and pause the video, think about what the answers are, try to tackle this yourself, type in your answers, and then when you're ready to go, unpause the video, and then let's talk about it together. All right, so hopefully you took a second to take a look at that. Let's go ahead and dive right into it. So what does this evaluate to? True and true and true and false. So think about it. What are and statements? They are false sticky. Everything ends up being false. Next we have true or true or true or false. False ors are true sticky, so everything becomes true here. We have not, true. Let's go about this the long way. So not true is false. Not false is true. Not true is false. Not false is true. So this should evaluate to true. That was fun. And then lastly, let's take a look at this conditional. Okay, so what does this print out? So x is equal to hello. Now this is a callback to indexing. Hopefully you all remember that as well. So if x bracket 0 is equal to h, print x plus world. Elif x bracket negative 1 is equal to O, print x plus goodbye, else print foo. All right, so think about this. Which one of these are true? Which one of these logical statements are true? So it actually turns out both line 1, or the first conditional, and the second conditional are true. But think about this. They are conjoined with else, if, and else if statements. So that means that the second we get a true statement, we evaluate to that, and then we jump out of the conditional and we don't execute anything else inside of the conditional. So therefore, that means this gets executed. Print x plus world, which should be hello world. And let's go ahead and check if our answers are correct. I'm going to go ahead and hit run. There we go. False, true, true, hello world. Hopefully you see this output as well. Here's a kind of a brain teaser. What if I have this? Take a second, think about what's going to happen in this conditional, and then we'll discuss the answer. All right, so you should realize that since we don't have an else if statement here anymore, that means that essentially this gets executed because this is an if statement, and then we jump out of the conditional. But jumping out of the conditional entails moving on to this conditional, because here we have another if statement. So essentially, we're also going to print this out, so you should see hello world and hello goodbye, the famous Beatles song. Very nice. All right, with that, let's move on to the next concept, loops. All right, so hopefully this is all making logical sense to you. If not, go ahead and attend office hours on Thursdays or the review session on Sundays, and let's talk more about this. Let's discuss what sorts of bugs you're experiencing here. And keep in mind, everyone, whenever you bring content or bring questions, you have to tell us what you tried first. Remember, the 15-minute rule. Try something for 15 minutes. If it still doesn't work, then reach out to human or ChatGPT. Okay, so let's take a second, let's collect ourselves, and let's keep chugging along. Loops. All right, so we have 2 loops in the world of Python. We have for loops, and we have while loops. For loops are primarily used for when we know how many times we should be looping. Maybe we're looping through a data structure. Whereas while loops are designed for when we do not know how many times we should be looping, or we just want to keep looping until something is false. All right, so I want to remind you all the structure of the range function, or rather the range object. The first argument we feed in is start, the second argument we feed in is stop, and the third argument we feed in is step. So I want you all to think about this. What will be the numbers that get printed out over here? And keep in mind there are some rules that are insinuated from this range object. So I'm going to use I as our variable because that's the variable we create over here. We write for I in range 0, 21, 1. Think about this. What number does this start at? I want you all to think about that for a second. Pause the video, and then when you're ready, unpause. All right, that should be 0, right? Because we specify that we stop at 0. Now let's think about what the next number is. I sub 1. I want you all to pause the video once again. Think about what this range function will result in. After we go from 0, what is the next step? Pause the video, think about it. Great. So you should know that we're doing 0 plus 5, so the next I is going to be 5. And then the next I sub 2, and we might as well complete this 10, because once again we're adding 5 because of that 5 over there, that step. I sub 3 is equal to 15. I sub 4, and I use this subscript, I sub 1, I sub 4, I sub 0, I sub 1, I sub 2, I sub 3, I sub 4. It represent all the different values that the I variable is taking on. Is going to be 20, because once again we are doing 15 plus 20. And then finally we stop the loop. And why do we stop the loop? Because we want to make sure that we exit the loop the second our I variable gets past the value of 21. 21 is our exclusive variable, or our exclusive value that we want to make sure we never hit or go past. So essentially what's going to happen is that, and this is kind of like a hypothetical, is that we are going to add 5 to our value. And then we're going to check, we're going to implement a check. Is this value less than 21? If it's not, that means we stop and we do not execute the next for loop, or rather we don't even execute that step of the for loop, we just simply exit out of this for loop. Now if you take a look at this range function down here, or pardon me, this while loop down here, you'll actually see something very, very similar. We start at I, and then we inside of our while loop we print I, and then we add 5 to I. However, there's something a little bit different about this. I want you all to think about the values that we printed out before in our for loop, which were 0, 5, 10, 15, 20. And I want you all to consider what this while loop is going to print out instead. Primarily, I want you all to look at this logical statement. All right. Once again, take a second, pause the video, think about that, formulate an answer, and then we will try to work on this together. All right, so if you said that the 20 is not going to be printed, you are absolutely right. This while loop is actually going to result in 0, 5, 10, 15, and then we're not going to print out the 20. And let's consider why we don't print out the 20. So once again, we start out at I sub 0 is equal to 0, because that's what we initially set it equal to. Then we go enter this while loop. We check, is 0 less than 20? Is our variable of is the value of I less than 20? It absolutely is. So let's go ahead and run through this while loop. Then we print out I, so that's going to output that's the console. Then we add 5 to our I, so that means the next value of I is going to be 5. And then we continue that pattern, just adding and printing. And then at some point we get to I sub 3 is equal to 15. And let's see what happens next. So keep in mind, we always go back to that conditional or at that logical statement to check if we can still be looping. We are going to check if 20 is less than 20. And this is a definite false. This is definitely not true. 20 is not less than 20. 20 is equal to 20. So that means we do not progress with the rest of our loop, and we just simply jump out of our loop and progress with the rest of our code. All right, so now that we've talked about for loops and while loops, I want you all to go ahead and try out these 4 questions, and I want you to either translate a for loop into a while loop or a while loop into a for loop. Think about that for a second, everyone. Pause the video, try to implement that yourself, and then we will talk about the correct answer. All right, so in the interest of time, I'm not going to go through every single question. Rather, I'm going to take a look at question 1 and question 3. And as you can see, I've gone ahead and implemented these answers. If you're interested in the correct answer, go ahead and pause the video, compare your code to my code. But let's talk about question 1. So here we have for I in range 5. Well, one thing that we also want to emphasize is that when we only have one argument inside of our range object, this indicates that we are by default starting at 0, we're stopping at 5, and then we're counting up by 1. Now, you might see another type of range object where you have 2 arguments, let's say 5 and 10. Well, in this case, this indicates that we start at 5 and at 10 and still count up by 1. So there's some default behavior going on here. And we'll talk about default behavior and functions later on. But anyways, so let's go ahead and take a look at the translated for loop. So since we start at 0, we're going to create a variable I set equal to 0. And since we're going all the way up to 5, exclusive of 5, that means we're not actually counting the 5. We're going to state I is less than 5. And then we're going to print out I, just like we do in this for loop. And then finally, we have to increment I ourselves. Keep in mind, whenever we have a for loop, we don't have to do the incrementing. That's done for us via this range object. However, when we're using a while loop, things are a little bit more manual. We have to implement the increment. All right, so that's question 1. And if you take a look at my output, you'll notice it's the exact same thing, 0 through 4 and 0 through 4. All right, so since I told you all I'm not going to do question 2 or question 4, let's move on to question 3. All right, question 3, what happens here? Yeah, okay, let me just comment some things out just to make room. Great, all right, so as you can see, for question 3, I have a while loop that starts at 2, increments to 10 exclusive. I print out I increment 2 to my I. So basically I will get all the even numbers from 2 to 10, not including 10. So we'll have 2, 4, 6, 8. And as you can see, that will also be the behavior here. And then we can implement this just by simply using a for loop that starts at 2, ends at 10 exclusive, increments by 2. And as you can see, we get the same exact line of numbers. So I really want to emphasize the art of understanding what's going to happen with your code even before you execute it. The last thing we want to do is to try something, get an error, execute again, get an error, execute again, get an error, and just like go through this vicious cycle of iterative development. That is not the way to go. You want to be an artisan about this. I'm going to use that terminology again. You want to be deliberate. You want to think about the consequences, or rather results of your actions. You want to apply intentional code. Trust me, you can spend 8 hours of workday doing this. That is not a good use of your time. All right, so with that, let's move on to data structures. All right, so we have 5 data structures to get through: lists, tuples, sets, and dictionaries. Now this is going to be annoying for me to ask you all this because it's been so many times, but I really recommend pausing for a second after I write down some more things and answering the questions yourselves. So a couple of questions I have about these data structures is, do they have an index? Are they mutable? Let's see, nope, yeah. Tuples, does it have an index? Is it mutable? And actually, yeah, no, that's going to be good. Does it have an index, and is it mutable? And lastly, dictionaries, does it have an index, and is it mutable? So take a second there, pause the video, think about your answers, think about the details of these data structures. This is quite an important detail to understand. All right, so hopefully you paused the video and answered all these questions. Let's go through the right answers. Lists, do they have an index? You betcha, yes. And in fact, I think I have a better way to represent this. Very nice. Does it have an index? Wait. There we go. Does it have an index? Yes. Is it mutable? Can we change it? Yes. Tuples. Does it have an index? Yes. Is it mutable? Absolutely not. A tuple will not let you mutate it. Sets. Does it have an index? No. Completely out of order, right? When you create a set and when you add elements to a set, it's almost random. There is some rhyme and reason to it. However, it's not predictable. There is no kind of assured way of keeping track of the order. And is it mutable? Yeah, without a doubt. Ooh, and then the most interesting one, dictionaries. Does it have an index? I'm going to say not really. It has a key. And is it mutable? Well, yeah, it is mutable, without a doubt. So that is how, that are the details of our 4 data structures. I think I might have said 5, but I really meant 4. So these are the 4 data structures that we should probably know pretty well, because not only do they show up in Python, but they also show up in other programming languages once again. And it is absolutely fundamental for our algorithms to work as they intend. or it is absolutely fundamental for us to understand these data structures if we want these algorithms, our algorithms, to work as they intend. All right, with that, let's go ahead and dive right into some data structures code. Let's see if I have any code for you all to dive into. Yes, I do. Perfect. All right. So everyone, once again, and I should have mentioned this before, but I'll link this in the description. We are taking a look at Phase 3, Week 2, 328 basic Python notes. So take a look at that, and you should be working through this. Hopefully you know this by now. But if not, then go ahead and access this folder and access the code block right underneath data structures. Once again, I'll pause the video, take a second to try to implement these, and then we will try to work on them together. All right, so as you can see, we have 3 data structures. We have a list, a dictionary, and a list, a set, and a dictionary. Here we have a list of alphabetic characters, or the English alphabet. Here we have a set of submissions, and we have a bunch of names. And here we have a dictionary of prices. All right, what is the output of the following code? Well, this is a callback to list slicing. Now keep in mind, when we have a colon and a number after it, with no number before, that means we are slicing a list from 0 to the second element. However, keep this in mind, this is exclusive. So that means that we will only get A and B. So basically this gives us a list of just the letters A and B. What is the output of the following code? Well, take a look at this set. What is unique about a set? Well, it only keeps track of unique elements. I probably should have mentioned this before. Keep in mind, a set does not have any duplicates. So we have Ulysses, we have Juan a couple of times, Ahmed a couple of times, and then Yasmin a couple of times. Well, what a set does is it decomposes this into just its unique elements. So check this out. Basically, if we were kind of like doing the job of a set, we would just find every single duplicate and delete all of them except for the first one. So this right here is the true representation of our set. All right, and what is the output of the code below? This one's a tricky one. Nothing. It's going to break. No subscripts in sets. All right, what is the output of the following code? Jasmine and submissions. So think about this one, hopefully you already thought about this. What happens if we try to check for membership? Well, this is going to be false. The most interesting detail about this, everyone, is that this is instant access. So keep in mind, with sets and dictionaries, we support instant membership checking. It's great. It's basically big O of one time or constant time. However, big O of n time is for lists. We'll talk more about that later. Lists. Right, let's go ahead and apply inflation to our dictionary. Now a dozen eggs is $4 instead of $3.54. Honestly, I've seen more extreme examples. This one's kind of a conservative estimate of inflation. Yeah, and then, but take a look at that. We pop dozen eggs. We throw the dozen eggs off of our dictionary. What happens if we try to run this? Well, hopefully you all got the answer of error. Key does not exist. And once again, just to verify the validity to my answers, let's hit run. Look at that, we have A and B. Then we have this list right here. Look at that, did not preserve order at all. It's always a good feeling to be vindicated by your code. And then by the time we got to this, we got an error. Let me go ahead and comment this out just to show you all the rest of the code. Yeah, false is what we got for Jasmine and submissions. And then finally we get another error. Dozen eggs does not exist in our dictionary because we've removed our dozen eggs from the key list. We've mutated our dictionary. All right, everyone. So that was a good chunk of material, but we're not done yet. No, we have list comprehension. Okay, last thing I promise, and then the video will be done. Once again, I really hope that you're all following along and implementing this code with me, because this is a really good review for what's coming up next, which is web scraping. That's going to be a lot of fun. Hope you're all excited for that. But anyways, let's talk more about list comprehension. So, why are we interested in list comprehension, first off? Well, and then second off, what is list comprehension? Actually, let me put that in reverse. What is list comprehension? Well, it's essentially when we create a new list quickly using a for loop and sometimes a conditional, and this is the general pattern that we take. We basically create a new variable, set it equal to something, then we use our list notation, our square brackets, and inside of the list we type in variable.method for variable and object. An object is usually another data structure. Another data structure. All right, this is equivalent to basically doing something like this, creating a new list, and then for variable and object, and then appending some variable, some method applied into that new list. If this is too abstract now, don't worry, we'll take a look at a couple of questions or examples again. But why are we interested in list comprehension, right? Why can't you just write this? Well, we are interested in reducing something called cognitive complexity. Think about it this way. Say you're writing an essay or an article or a story, and you want to evoke some sort of emotion, give some sort of fact to a reader. If you can edit your piece in such a way that it reduces how many concepts the reader has to think about, but still evokes that same exact emotion, you've just done something great, right? Same exact concept for writing code. We want to evoke the same exact action, but in the least amount of code. Not only that, but this is also easier to read. I mean, take a look at this and this. I'd much rather take a look at this. Anyways, and in addition, it's usually more efficient. The engineers who create Python do some magic in the background to make sure that this thing is always faster than this thing. Don't ask me what it is. I'm sure we can peel back the layers and figure it out, but all I know is that this is faster, so we definitely prefer this. And in the world of engineering pipelines, we value efficiency because you definitely don't want to take up too much CPU of whatever server you're using. All right. Anyways, let's go into some pattern or into some code once again. But basically, first of all, or rather, before we get into that, keep in mind we can apply a condition by placing the condition at the very end. For a variable and object, if condition, and then variable.method in the beginning. This is the equivalent of doing the following. Creating new lists for a variable and object, if condition, new list.append variable.method. Look at that. We've successfully managed to condense 4 lines of code into one easy-to-read line of code. This is the heart of Pythonicism. Oftentimes, when you take a look at Stack Overflow questions, you might see people using that word very freely. Like, oh, this solution is Pythonic, or this solution is not Pythonic. And then, of course, they hike up their glasses, right, and say... Anyways, sorry, Python developers. Okay, let's keep going forward. Okay, I did this already. Okay, once again, pause the video, take a look at this code block. I want you all to try to implement this yourself, and then we will try this together. All right, so hopefully you all gave this a good old college try, but I'm going to go ahead and implement this live. So in fact, honestly, this is just as easy as a copy and paste. Yep, as you can see, this is list comprehension. Let's try this out. This is list comprehension. And then finally, let's try this out. Notice what's happening here. I'm not even thinking about what I'm doing, which is not a good thing to do, but I just want to show you all the simplicity of what list comprehension really entails. Look at that. Variable for variable and object, if condition. And lastly, and this is something that you're going to do for your code fixing. And there we go. Yeah, and as you can see, this basically filters all scam emails. I should have labeled this spam. Scam@gmail.com. Probably not going to listen to them. Bob@scam.com. Definitely not going to listen to him. Realperson@gmail.com. A little bit suspicious, but you passed the scam test. All right, so that right there is list comprehension. I encourage you all to continue exploring these notes. We'll talk more about functions in the next video. Definitely take a look at lesser known data structures. A string is a data structure. Who knew? Well, yeah, I guess we did. Abstract data types. We have queues, stacks, trees, all important data structures to understand for programming interviews and just general computer science knowledge. But let's go ahead and finish up this video with the email fixer code. Once again, take the same approach, pause the video, work on it, and then we'll go over the correct answers. All right, let's go ahead and take a look at each question and implement the necessary fix. I'm going to go ahead and leave this doc string empty for now. We'll talk more about that in the next video. This is a good segue into the next video, actually. So let's go ahead and take a look at question 2. Fix this for loop. Well, what's going wrong with it? Well, we definitely don't have a colon at the end. And notice how we write emails twice. Does that make sense? 4 emails in emails. Doesn't even make linguistic sense. And then take a look at this. We're trying to check each letter in email. This is a pretty good detail to see because this basically points to the bug of plurality. This is what the developer wants to implement. They just accidentally put an S there for some reason. So for email and emails, that's much better. But honestly, keep in mind, it doesn't have to be called email. Python does not abide by linguistic terms. It's a language for everyone. We could even type in U for U in emails. We could even do for underscore in emails, which is a good way to throw out a variable. We'll talk more about that later. For T in emails, but just for the sake of simplicity, we'll write for email in emails. Okay. Coworker was stumped at this conditional. How can we create a conditional that checks if a letter is a valid non-alphanumeric character or an alphabetic character? Well, we could do this if letter dot is alpha. Think back to your or statements. We want to check if it's an alphabetic character or if it's equal to the @ sign or if it's equal to the dot. Then we want to go ahead and keep it. Otherwise, we are not going to concatenate it to our new string. I really want to caution you all to your statements or your conditionals. Make sure to not implement this, because this is actually not a valid logical statement in the way that we intend it to be. This is what we call a semantic error. This is something that is not necessarily a Python bug, but it is a bug in our logic. Basically, if we do this, what's going to happen is that these two strings are always going to evaluate to true. And the reason that happens is because Python always considers strings to be true. If you don't believe me, let me demo this for you all. All right. Let me share my entire screen. Behold. All right, check this out. If me print all right, look at that. It considers strings to always be true. Some people might consider this a little bit weird. JavaScript, I think, does some more fancier things with this. However, we're not studying JavaScript, we're studying Python. So, word of warning, do not use strings by themselves in logical operators or in conditionals. This is always going to evaluate to true, and we are going to unintentionally include strings that we don't want to include, or characters that we don't want to include. There we go. There we go. All right, re-implement this inner loop as a list comprehension. No problem. It's going to be a little bit of a long one, but not to worry. All right, and then I'm going to go ahead and comment out the rest. All right, and then honestly, I don't want this to be expressed as a string. This is kind of like a hidden debug. We want to go ahead and turn this back into a string. So I'm going to go ahead and write new string is equal to quote dot join new string. And so that's that. And as you can see, this return statement is a little bit erroneous. We'll talk more about return statements in the world of Python in the next video. So let's go ahead and return clean emails instead, which is the list of our clean emails. And then lastly, as you can see, this is a buggy function call. We'll talk more about this later on, but we need parentheses. We always need parentheses after a function call. Okay, so that is that. Let's go ahead and run this line of code without relying on the top right run button. I want you all to take the wheel and use the terminal. Python challenge to email fixer.py. Okay. Ah, yes, I missed one. It's append. Sorry if you saw me do that. Maybe you were yelling at the video. All right. So this is not going to output anything. I'm going to wrap this around in print statement. And there we go. Look at that. We have, oh, okay, so yeah, I kind of messed up there. I put a lot of @ symbols. We're going to consider this to be valid. Really, these @ symbols shouldn't be there. I violated my own prepositions or my own preconditions, also with Yasmin as well. Yeah, why does that happen? Anyways, I'm going to remove this. We're going to pretend like that didn't happen. Let's see what happens this time. There we go. Bob at Gmail, Yasmin at Yahoo, Ahmed at company.com. All right, so that's how we apply all of our knowledge to this line of, or this Py file. In the next video, you're all going to see how, or rather, we're going to get introduced to some old concepts and new concepts of functions. Thank you all for sticking around. Appreciate you watching this video. Let's go ahead and I'll see you